My name is Joseph Lunar Jr., and my presentation is on carbon capture and storage. So what is carbon capture and storage? Carbon capture and storage is a technology process in order to reduce climate change. We all know that climate change is a real big detriment to our environment. It is causing a lot of things to happen. It's causing our glaciers to melt, uh, obviously causing our environments to get warmer. It's just not a good thing for our environment. And this process, carbon capture storage, is put into place in order to reduce this. Um, in a nutshell, carbon dioxide is taken from power plants or factories or commercial factories, stuff like that, and is taken from those power plants and is stored underground, is pumped underground. I'll get into the whole process a little bit later. Um, but the main goal, like I said, is just to reduce carbon emissions. Carbon emissions and climate change kind of go hand in hand. Carbon emissions is one of the leading factors in climate change and increasing climate change. This information is taken from Xthink 2015. That is one of my references. So now we're going to talk about the process of carbon capture and storage. First, like I said before, is this collection of carbon dioxide. You collect this carbon dioxide from the power plants, the factories, uh, industrial factories, things in that nature. The second step, you take the carbon dioxide after you collect it and you compress it to liquid form. Or you can just keep it in the flue gas form. And the flue gas form is the original form that is collected in. The flue gas is basically the gas that comes from these power plants. It just has a high concentration of CO2 in it. So then the third step is you take the liquidized carbon or the flue gas form and you just pump it into the subsurface. You just pump it underground through multiple series of pipeline, things of that nature. And the fourth step is the carbon dioxide is then stored in depleted oil and gas reservoirs, coal beds, deep saline aquifers, um, or another thing is geological formations, so rocks, sediments. That seems to hold carbon dioxide really well. And it's just to get it out of the atmosphere. That's the main goal. And this was taken from Bandila 2020, another one of my references. So now we're going to get into the chemistry and carbon capture and storage. This is a huge part. However, I kind of picked the two most best focal points that I could probably talk about. That would make sense. The two are turning to solid absorbents or solid sorbents. It just has lower heat capacity. This is kind of what they are. Um, and the second is metal organic frameworks. These metal organic frameworks, they're kind of taking the carbon capture and storage community into a buzz right now because they work really effectively. They're most commonly known as MOFs. So first are these solid sorbents. They're essentially just solid particles that were constructed and made by the scientist last name of Jones and his team at Georgia Tech. These particles are made of polyethylamine silicon dioxide and hollow plastic fibers. Um, they're basically just bundled together in the subsurface tubes or the tubes in the pipeline, and they're bundled in those tubes and they pass the flue gas through it. That's why I mentioned the flue gas before, because it's not really the liquidized carbon. I mean, it can be, but it's more effective with the flue gas. The particles hold a lot of carbon dioxide. That's one of the main goals. That's why they're used. They're bundled in the pipelines. You pass the carbon dioxide through it. Boom. The carbon dioxide is retrieved by running hot water through the tubes. So you can actually take the carbon dioxide from these tubes and from the solid sorbents, run hot water through them, releases the carbon dioxide, and that essentially just gives you more of an advantage to move and store the carbon dioxide somewhere else. And this information was taken from Peli 2015, one of my references. Now we talk about the metal organic frameworks, or MOFs. I'll be mentioning them as MOFs, just to give everyone a heads up. They're porous structures built of metal ions linked together by organic molecules. This is kind of what they look like. This picture shown here. Now they have a larger internal surface area, making able to hold a lot more CO2 than these solid sorbents. However, most companies are straying away from these MOFs just because that they're just super expensive. They're super expensive to make, super expensive to put in. It's kind of the same thing as the solid sorbents. They're kind of used in the tubes. However, it's a lot of work to get these metal organic frameworks together and to make them right. So a lot of companies are straying away because they know these solid sorbents work, so they don't want to spend the money. Um, they don't want to spend the more money just to make these metal organic frameworks because the solid sorbents work. They do work a lot better, but They're trying to make ways to lessen the cost to make these. So just like solid sorbents, these MOFs, they can be heated up to 50 degrees Celsius, and the CO2 comes off. So you can essentially just heat these things up, CO2 comes off. That gives you a better chance to store it somewhere else. Kind of the same way these solid sorbents work. And this information was also taken from Peli 2015, one of my references. Here are all the references mentioned in this presentation. And any questions? Thank you.